Namaskar, I'm Harpreet Kaur and I welcome you all to our live and interactive session. You're watching us on PM eVidya channels 6 to 8 and also on our YouTube handle NCERT Official. This is our 7-day, 7-hour online training program on integration of virtual labs for teaching, learning and assessment at the middle stage, which means in this entire journey we are focusing on middle stage schooling, that is classes 6, 7 and 8. Today we are in day 5 of the training session and the topic that we have taken up is virtual lab for mathematics. Well, we all are familiar with the laboratories for science and some for mathematics as well. But what about virtual lab for mathematics? I mean, when it comes to learning of mathematics in a traditional way, we have always seen that how it is done in classroom teaching, chalk and duster method, and we are writing and copying the things from the blackboard and understanding the things simultaneously. But when we do it in virtual mode, how is it making all the difference in understanding the complex concepts of mathematics? Well, we will definitely divulge all the details regarding the same in this session of ours today. But the session is live and interactive as always, which means you can also participate in it. So please take down our phone number, which is 8800440559. We also have a dedicated email ID for you, that is diksha.training@ciet.nic.in. And since we are streaming live on our YouTube handle NCERT Official, please go to the live chat box or the comment section and put in your questions there, your suggestions, your feedback. It means a lot to us. And now it's almost time for me to tell you about this very important journey of ours, which is a training session, and hence there is going to be an assessment as well on the last day of the training session, that is on day 7. So if you attempt the assessment and you score more than 70%, you will be granted a certificate. Let me tell you that assessment courses will be released soon on CIET website. So you please log on to the website and go through the guidelines before you attempt the same. And now, once again, we have arrived at the moment when it's time for me to introduce you all to our expert for the session, who will definitely take us to this virtual world of learning mathematics in a totally different manner. We are joined by Mr. Vaibhav Singh, Service Project Manager from ETU CDAC, Mumbai. Sir, namaskar and very warm welcome to the session.
Namaskar, ma'am. A very good morning.
All right, sir. And sir, it's going to be one very important journey. So, before getting directly into the virtual lab scenario, I want to understand one thing from you. What exactly mathematical labs are? Because, it's not that everybody has gone into a mathematical lab. I've never been there as a student myself. So, I want to understand what exactly the mathematics lab is, and if we talk about the challenges that we come across in teaching and learning of mathematics in classroom scenario, then what are those?
Yeah, sure. So thank you and welcome all the viewers of the NCERT Official. Today we are having this session on virtual lab for mathematics. So as you asked before coming to the lab, I will give you a brief background why these labs are very much important and why we have come up with the idea of these virtual labs. So if you see, what is the background? So if you type background, you can see a laboratory is a key component. So in our schools, we have seen that we have a physical laboratory where students come and perform the experiments. Majorly, these are for science only. But now after this NEP recommendation of 2020 and for the virtual labs, we are having mathematics also as a very important subject. So where we have tried to create some virtual labs which will help the students, and these gaps which are there will be filled. Okay. So we know that school education in India also faces many challenges, that lack of infrastructure, including lab in many of, not in the city, in the rural areas, we have many challenges like this. Also, students have the knowledge in the session, theoretical knowledge they have. But when it comes to practical implementation and doing the simulation and performing those labs, it becomes a problem. So these are the background and the challenges we thought of for this virtual lab. Then coming to the approach, that we strongly believe that the technology can expand the boundary of the physical lab. One thing which is a very much confusion to all the users, that it will replace the physical lab. So it's not like that. We are just augmenting and amplifying them, that they can do unlimited times and with no repetition and no cost. They can perform it as per their choice and as many times with different values in online mode. Also over the internet, on a laptop or a desktop or a mobile phone or a tablet, they can perform the experiment from their own space, at their own pace also. So
Right.
every student can perform the experiment as per their requirement and get the knowledge. And also it aims to bridge the geographical constraints. Like if you have a school at different areas, and during COVID we came to know that the schools were not open
Yes.
and children were facing very much problem. So these labs augmented there and helped students very much to understand this concept of virtual lab and
Okay.
how you can virtually perform the experiments. Then challenges, especially for mathematics, that we have thought of, that you can see that conceptual understanding. So you can see students of, we are talking about 6th, 7th, 8th grade, they are very small classes. So we can see they don't able to differentiate between what is difference between area versus perimeter, and what if they have learned a concept and how
Yes.
they implement. So in simulation, the virtual lab, they will come up with some activity where they will perform the lab, and they will understand that, oh, the topic which I have learned, this can be implemented like this. Also, with regular session of teaching learning, if you implement this in the class, so the interest part, when we see the student lost the interest in a theory part or for long lectures, so this can come in, and or after some time, reflection points can be added, and student will get an interest by performing this activity. Then problem solving skills will be developed, because
Okay.
here in the scenarios we will ask students question like this, that in a triangle, if one side is this centimeter, one angle is this, then what will be the other side? So they have to think a lot and then come up with the solution and the answers to this. So it will solve their skill, increase the skill of their problem solving. Then the foundation, the weak arithmetic foundation, where addition, subtraction, multiplication, division, so many, still now we get confused in some of the topics. So here it will help the student to get this topic very much clearly, and they will be very much fluent in that. Also, abstract thinking is the part where it will be useful for them, and we also see that the formulas are very much important. If come to a arithmetic formula, that what is the formula for a plus b whole square, what is a plus b whole cube. So many students get confused there. So when they perform this lab actually in the environment, they will have some tools with drag and drop and all these things. It will stick to their mind. So they will very much be familiar with the topic, and it will be long lasting in their memory and very much easy for them to understand the topic. Suppose also in mathematics you see there are 3D shapes like a cylinder or a cone or a frustum. So in the physical, we are not able to, class mode, we are not able to make the student understand completely. Here what we have come up, that we have created few 3D labs. In 3D labs, you see the student can see the shape in the 3 dimension, perform the experiments on those shapes, that to find the area or the volume or anything, and it will help them once they visualize the concept on the shape. It will be easy for them to understand and take it forward from there. So these are some of the points which we are addressing through virtual labs, where the student will be very much familiar with the concept.
Well, sir, I totally agree with all the challenges, or these points that you've mentioned here, because as a student, I remember that I couldn't learn many abstract concepts in regular classroom teaching scenario. First of all, teacher was in a rush to complete the syllabus. It was chalk and duster method. And also at times when you do not know the real life application of the concepts that you're learning, they do not remain intact in your memory for a long period of time, and you end up doing cramming. I myself remember cramming theorems of geometry. Now, I want to understand here that how these mathematical labs are designed in a way that they can help the students, and or they can help us to overcome the challenges that you just mentioned. What are the salient features of these labs?
Yeah, so you correctly mentioned that these are the problems which we have tried to fix it while creating these labs. So I will tell you a few of the salient features of these labs, and how we have created this lab, how much authentic the content is, and then I will come with the core ecosystem. So first of all, that we have strictly followed the CBSE manual, lab manuals. So you see on the internet there are many content is available. Once students come for this virtual lab or a video, they can got stuck somewhere for like watching the videos or the lab. So if they come to our portal, our Diksha virtual lab portals, it is
Okay.
all aligned to CBSE curriculum. So they will not get lost, and they will have the authentic content which is duly verified from CIT, NCERT, as well as the teachers. Also, as I was telling you earlier, that few labs of mathematics are in 2 dimensions and few are in 3 dimensions. So the cylinder, cone, frustum, all these shapes have been created in 3D. So it will feel them a real world environment. That what they are seeing in the actual, if you see a bucket in their home or in the school, so they see how the area of that bucket or the volume of that bucket can be calculated. So those simulation model actually the real world behavior, and also on each step the intuitive feedback and guidance. So what we are trying to say it here, that suppose there is a step that you have to put a value of sides of a triangle or a rectangle to create a rectangle or triangle, and if student is not able to properly draw it, so here the feedback is given to the student that no, you have mentioned put this value wrong, or this formula is wrong, or this concept is wrong. So a stepwise guidance is also there. So it is an interactive part. So students have to come, perform and get the knowledge, and the system helps them to achieve the aim of the lab which has been designed. So these points cover all the overall scenarios of that. Now if we come off the 3D representation, or we were drawing our geometrical shapes, so we have a dimensions there given, that if you are going to draw a circle, then what should be a radius of that circle. If you are going to draw a triangle, what should be the side of a triangle. And for each lab, suppose there is a lab of mathematics where a scale is required, that we are asking a student to find the midpoint of a line. So we are providing a scale, so a student can easily identify that this is the midpoint. Then also, if in some lab we have to cut a triangle or rectangle, or we have to rotate it clockwise or anti-clockwise to fix it, to get the prove the theorem, etc. So those tools and features are available. Drag and drop and superimpose. That if you are saying that these two triangles are congruent, so you can see that we can drag one triangle from one place and put it on the other. So student when will do it, it will come to know, no, all these sides and angles are matching. So this theorem is verified. So these are the tools which are based on each lab, that what relevant tools we can, affordances we can provide, we have given in each lab. Then as I told you, instructions are provided on each step, that what student have to do, along with the animation and procedure. On each step the instructions are there, so student have to follow those instructions if they got stuck somewhere while performing the lab. Then also we have a workbench observation. Workbench we call the area where the student have to perform the experiments, and what the student is doing. Suppose they have marked a point P on a line AB, so that will come in the observation. So each step is taken care of, and on completion of each lab we have put the inference and conclusion. So suppose we have to find the volume of a right circular cone, and once the student have reached to that level, so it will be shown to the student, yes, you have completed the lab, and this is the conclusion of the lab which you have performed.
Okay.
So this is very much relevant to the illustration to the workbench. Now coming to the ecosystem, that here also in virtual labs we are not just providing them a lab that they come and perform. We understand that if student is coming for a topic, so he or she should be familiar with the complete thing. So it's like that, suppose the lab is of area of circle. We just take example. Now first the theory part. Now what is the area of circle? How we need to calculate, with the help of diagram and applications we have make that understand to the student. Then also the procedure, that how they have to perform in your school, which we have shown them, and how they have to perform here, and what are the learning outcomes. Suppose the student is performing this lab, so how much things, what is they are going to learn, that has been covered in the LO part, the learning outcome part. Then also if there is a lab where some graph has been drawn, now there is a bar graph or there is a chart which has to be created for a OGIF type or a sine inverse lab. So everything is provided in the system itself. The student had to just plot them, record the measurement, and they're done. And the main part comes is that we have a viva voice questions. So you see, with each lab we have 10 questions, multiple choice questions which we have provided. So now a student have learned a topic, then they will perform the experiment, and then they will have the viva voice. Now it is a self-evaluation type system that we are making, that student will come to know that whether they have understood the concept properly or not. And the core is the simulator, which I was telling you, that students have to perform the experiment, and they have to interact with the system with the help of a keyboard, mouse and instruments, and they will complete the lab with the help of instructions which has been provided. So this is the complete ecosystem and the features which we have taken care of while creating these labs.
Well, so they're really interesting because they're not just aligned with the curriculum of CBSE, but you mentioned the content is really authentic and carefully designed. So yes, you can customize the lesson plans as per the need and requirement of the students. But what I want to understand here is that what are the effective usage scenarios of Maths Virtual Lab? Are they really helping the intended users?
Yeah. So now I will come to that part also, that how this system can be used by the students. So you see, we are recommending few of the steps which can be used. We strongly believe that that students and teacher can come up with more many ideas than how they want to use and to implement this in your daily teaching learning process. So it is not just for a demonstration in the class. What we are suggesting that we can prepare the student while taking them to the physical lab. Now see, you know that today in your curriculum you have a lab at school. So in the morning in your session or day before that session, you can play this video or play this animation in the class. So the student will be familiar with this lab and they will take less time and they will perform this lab very good in the physical lab. Also, suppose you have completed the lab, then you can put it as a backdrop and you can ask questions to the students. So this can be a more engaging way. Then also in the lecture, while you're taking the classes, suppose you are making a topic of a volume of a first term, then you can engage this activity. So this interactive activity will help them to more clearly understand the concept and the student will be more involved in your teaching learning process. The active learning strategies which can be interweaved with the usual lectures which I was talking about, that the teacher can use it as per their requirement and then based on that they can plan their session. So it will be a very much interactive session and student will be involved very much in this activity.
Right.
Also, if you want to give the student as a homework, so you have taught a topic today, suppose you have taught a sine inverse curve, you ask the student that go home, open this virtual lab website and perform this experiment and tomorrow come up with the questions what you have. So next day you can discuss this in the classroom. So it will be very much effective at that way also. And also, as I was telling, the viva voce part is there. So the viva voce part will encourage them for the self-evaluation. Now it's like that the students have learned some topic and they want to test that whether I have understood properly or not. So they just have to open that and then answer those questions and the result will tell them that whether their answers are right or wrong. And there also we have an intuitive feedback. I will show you that in demo part. So student will get to know that whether they have understood the concept
Or not.
properly or not. Now these are the proposed activities for how this can be used. So this is just an activity for 5 to 15 minutes which we have thought of, which can be done in the classroom. Now you ask a student that what will happen if. Now this is a theorem that we are taking a height of a cylinder of suppose something value and a base of some value. Now you ask the student change the height to this value or change the radius of this. So the student have to calculate what next they have to do and then they have to come to an explanation that what is the purpose of this, how is the process we are performing. So this activity can be based on the particular purpose and learning objective of the lab, that which lab you are currently teaching or you are showing to the student. So why we are recommending this, that students are very much curious when give them this type of activity. So based on, rather than giving a usual plan which is there in their manual, just tweak some values. It's like change the value of this side and see this angle. If you change, how we are going to calculate the in-center of a triangle or a circumcenter of a triangle, or how it will reflect to the area. So you tweak the values, ask the students now predict what will happen. So they will get engaged, they will perform it as per their new values and come up with the solution. And when the answer comes, they will come to know that, oh, actually based on this is defined and we have come to this conclusion. So this is a very much active learning scenario which can be implemented by the teachers in the classroom or the students. Then as teachers can use this in the classroom on the lab, that before taking the lab, they can explain to the students that before this today we are going to perform this lab where we are going to find the surface area of the cone. So like that we can perform and we make the student understand then what is the procedure. In a lab we do not get the match that sufficient time as I remember of my school time. So we have a less time here, so where we can in advance we can tell the procedure to the students. So the students will be very much equipped, and when they see demonstrate that phenomena, so they have in the mind that they have to go to the lab and they have to perform these steps and complete the activity. Also you can set the expectation that now you are going to complete this lab. In this lab, this is the expectation or this is the learning outcome which we have thought of. So you have to come to that. And after the lab, suppose the lab is done and again you are in the lecture, you can frame questions. That now this lab we have covered and performed like this. Now what will happen if this value will change, or how you completed this step. So like this, we can frame the questions, review questions based on this lab as a backdrop in the classroom also. And I was telling you that the creative teacher and students can come up with many more innovative uses, that how they want to implement these virtual in their daily teaching learning process. For students also, we have thought of some of the points which they can think that if the student knows that today they are going to perform this lab, they can get it familiarized from their own. Whereas these are virtual labs and available on over the internet. So over their mobile phone or their laptop or a desktop, they can perform this lab and they can try different variants. We students are very much curious, so they want to change some values.
Yeah.
That I will change this. What will happen if I change this value, or what if I drag this circle to at this point? So like that they can vary, because these are all online. We don't have to actually equip them with the resources. They can perform it as many times they want to perform. And suppose a student has done the lab and it's not very much clear to him, and there are exams later on in the session, so they can do a revision also. So in the revision part, they can again come to the lab and perform the same experiment again, and it will be very much useful for them to understand the concept or revisit the concept very much. And also we can use this lab to reinforce the concept, answer questions they may have. It's like what the students have the curiosity of the lab, they can in detail can have with this lab.
Right. So,
this is it.
yeah, so we can say that it's not just about teaching and learning, it's also about feedback and evaluation. That's dot on time. And also the students enjoy learning at their own pace and convenience. They can try the hit and trial method and they can go back to it, get the feedback instantly, and their interest remains intact while solving these complex calculations. And nothing is abstract now, because every visual is there in front of them, and animations, they're very catchy. So basically we're also catering to the inclusivity part of bringing everybody together on the same page and making them understand the things in a similar fashion. Now,
Yes,
sir,
yes.
this makes me really curious to know about the skills and the topics that are broadly covered under the currently available labs in mathematics.
Yeah. So if we coming up the topic, that how much topic we have covered. So we have a plan to cover all the labs starting from class 6 to 12 for all CBSE labs which are mentioned, and we have come up with the number of 120 or 145 labs to complete, and which are already in the process of uploading to. Many labs are available on the Diksha virtual lab platform, and others are also will soon be uploaded there also. So if you divide them in the topic which we have covered, so there is a algebra. So they are linear equation, quadratic equation, arithmetic progression type labs are there. If they are equations topic, then the surface area of volume, sphere, cone, cylinder, frustum, all are there. And if there is a plane, so there two planes are intersecting, how they are going to slice it, what angles they are forming, like that labs are available. Then geometry, we have a property of triangles, that Pythagoras theorem, how we are going to prove the Pythagoras theorem. Circles, tangents, chords, that on a circle, if from one point, how many tangents can be drawn, how if their equivalent lines are not over there. So like that, topics are there, and the coordinate geometry point has also been covered in the geometry part. Then coming to statistics and probability, we have a data handling and representation, that suppose we have divided the class into group of some people, and we have some data class wise or the year wise, and we are creating a bar graph or a chart. So how student will be able to understand that concept has been covered. And the probability of this is a very important topic in mathematics.
Yeah.
So based on that, we have created labs on probability also, which will very much useful for the students. Then coming to number system, the real number. What are real numbers? Because many students get confused in identify what are real number, whole numbers, and natural numbers. All this. Then the expressions and activities on the number line. What activities can be performed on a number line. Then LCM and HCF activities, which is also very important. So labs are very much created like that, so that they will have a very clear idea of how they need to find the LCM and HCF of the two numbers which are provided, and all these are dynamic. They are not hard coded, so they can choose the values of their choice and they can then perform the labs accordingly. Then trigonometry. So what are the trigonometric ratios and identities, and also how to apply this trigonometry in the application, like height and distance of a building, like using a clinometer to find the height of a building, like activities have been created. So these are some of the broader topics which have been covered. There are many more labs and on different topics which are there on the portal, from which the students can get benefited. And these are the features which how we have covered the topics. Now, if you see that there is a lab of an angle in a semicircle, or a property of a parallelogram, or relation and function, set theory, section formula. So these are the list of the labs which we have, and then what are the features which are very much important there. So we can see shape formation, draw and cut, plotting of points, angle, distance measurement, drag and drop, rotate, animation. So these are the features which are given on the lab. So it is like that, based on the one lab, what are the affordances or tools the student will need. Based on that, we have implemented the features. Now, if you're solving a solving a linear equation of Pythagoras theorem, then there is a drag and drop and rotation is required. Now, if you're coming to 3D models like algebraic identities, a plus b whole cube or a cube minus b cube, or a volume of a cuboid which we are identifying, or conic section, frustum of cone, solution to quadratic equations. So for this, we have visualizations that we have different shapes available. So based on those shapes, the student will be able to identify that we are providing a cylinder and we are providing a knife. They have to cut that cylinder in equal parts and then arrange it to make some shape and then again find the area of that shape. So based on that, it will be very much interactive for them that they will draw, cut, and then they have to rotate. That there is a triangle they have cut, they have to rotate it again and then move it, drag it to the other triangle to find that whether the sides are same or not. And on-click animation and imposing of the images. So these are the features which are given for a 3D lab.
Okay.
Then for the chart topic, which I was telling you, that we find to maximum area of a rectangle with same parameter, or a ogive, or a curve for a plus or a minus, max or minimum. So bar chart and line charts are given. If you are going a labs of some, say, sine inverse or for that type of labs, we have a proper graph plotting is there. So student will be very much able to understand how this topic and how these experiments work. And then there are labs of paper folding, that how with the help of paper fold they can create a square, rhombus, angle bisectors of the lab triangle can be done. And then grid functionality. That fraction is a very much important topic. If you know that subtraction of fraction, addition of fraction, multiplication of fraction. So with way of the grid functionality, we have created these labs where student will be very much familiar and very much interactive in doing the experiments in online mode. Also, this is a new topic which we are going to implement. Few labs are ready and more in progress. If you see that we have created games also. Because game is something that these kids are very much involved in that and they get very much connected. So suppose there is a lab which we have created to find the area. In that there is a theme type park where they have to go. They have to see different shapes and see that now this is a rectangle, we will find the area. This is a square, we will find the area like that. Then shape zones is a 3D game which we have created, which we have done, that where students have to come and see there is a hat right there. So hat is of a 3D shape and it can be a cone. If there is a ball, then they have to pick a ball and see the features that it can be a sphere. If there is a cuboid. So like that they have to identify the shape, and then the probability fair. One lab is there. In there, the student have to find the probability that their random balls is coming of which color, and they shoot a balloon somewhere. Then how they are going to calculate the probability of that part of point toss like that. So in 3D AR VR, more maths we are coming up. So this is the new topic which we have introduced. So that student will be very much interactive and in a very much phase that they will perform the labs, and by then it will be easy for them to understand the concept is very much. So these are some of the screenshots of the lab which are already available and have been developed. I will give you a demonstration also later on. For these are the topics which we have covered and scenarios which are there.
Right. So I think I must say that when we talk about the gamification of anything, it brings a very engaging and playful experience in the picture, and that's how children learn very smartly when it comes to complex concepts of mathematics specifically, I must say. Now I also want to understand about how many classes are there and where actually teachers and students can access this Diksha lab, and how they can perform experiments in a virtual mode, because all we need is an IoT device and good Wi-Fi if we want to access all the features, right?
Yeah. So as I was telling you that the labs are available via Diksha platform. And the total number of labs I am talking about is around 111 labs bifurcated in different classes for class 6, 11, class 7th, 8, class 8th, 10, class 9th, 38, class 10th, 26, class 11th, 9th, and class 12th, 9 labs are. So these are 111 labs which are available, and more we are adding. So target is to reach around 150 in this academic year itself, and then next phase we can come up with the more labs. So these labs are available there, and over the internet, they only need an internet, and they can open the Diksha portal, and then they can perform these labs and student can use. So this is our Diksha portal. Every user can note it down the website at diksha.gov.in/virtual-labs and .html. So I will not stop.
But sir, before you move ahead, I just want to ask one more question. Do they need to sign up, for accessing Diksha labs?
Yeah, they need to create basic details they need to create, because there they are, this Diksha is storing that, the system is storing that the user and their track their progress and
Okay.
what challenges they are facing. So like this, they can have a basic Google login or basic with the NIMO number. They can register on the Diksha portal.
Okay.
Once they register, there is no need to register again, and they can perform the experiments available.
Great.
Which
Okay.
yeah,
Yeah, now we can go ahead with the demonstration part now.
yeah.
And which class you are taking?
Now, I will give you a demonstration of classes 6 to 12, a 1-1 lab based on the time which we have.
Okay.
So we'll start with class 6, and then we will come to, we'll try to cover the topics which are more useful to the students, some 3D labs or some graph labs based on the topic. We will see that.
Right, sir.
So the users can see this is our portal, diksha.gv.in/virtual labs. On this page, the content is added, and Diksha is very beautifully bifurcated and have made the available content available. If you see the class 6, grade 7, grade 8, grade 9, 10, 11, 12, they have bifurcated. And if I click on explore, you can see both mediums are available. What are the subjects which are available in Hindi, and what are the which are available in English. So if you see mathematics, science, social science, Hindi topics are there, and based on that same for all classes, this has been done. Now I will click on the mathematics. Now you see, we come to this part. So here again, it is very beautifully mentioned which are the labs which are been recommended by NCERT or CIT. So in the NCERT curriculum, you can see these are the many labs which are available there, and against each lab, this activity has been developed. So as I was telling you that most of the labs are in phase of uploading in this Diksha platform. So about many labs are there on the Diksha, and again all are in the process of uploading. So you can see this lab is available, which is an equivalent fraction, that how to find a fraction given to an equivalent fraction. Then you can see other labs on the right hand side. So for those labs, the content is available. A user can just click here, and you can see there is a learning resource which is available here. So you have to choose the topic which you want to learn, and on the left hand side you will see that the lab is available. So I will click on the start. So how we have designed this lab, I will, in our first lab, I will make it more clear so that all the users will come to know. So first is the topic that we are going to perform the addition of like fraction. Now what is the objective of this lab? To find the sum of fractions with same denominators, which usually we call like fraction, and what will be the LO. So the learning outcome for this lab will be, student will be able to learn the addition of fractions with same denominator, right? We will click on the start, and here our menu comes that we have to go to workbench to perform the experiments. But before going to workbench, I will give you what are the items which are available with each lab. So first is the theory, which I was telling you that in the core ecosystem part to all the users that we have a theory here. So what is the objective of this lab? If there are any prerequisite knowledge which a student must know is available in the prerequisite part, and then what is a fraction. So the basic definition of the fraction, what is the topic and what we are going to use is mentioned in the theory part with a relevant example, that what is a fraction, parts of a fraction, what is a like fraction, and in addition of like fraction with one example we have given in the theory. So this part student will be very much interested, and they will understand the concept first, and then they can jump to the lab. Again, there is a procedure part. So the procedure is that the steps which are provided to each student, that how they have to perform this experiment. So the first step says they have to create a grid. We have to choose a value, then we have to create a grid, then we have to mark something. So all steps are there, and then in the last, the observation which I was telling you, that the student will be able to learn the addition of fractions with same denominator. This is the observation which will be concluded. So the procedure part is there, and then after that animation. So the animation is a recording of the lab. It is basically we are recommending to teachers so that they can play this animation in the classroom, and after watching this animation video, a student will perform the actual lab in the simulation part. So the animation part, we have all the steps that what we are going to learn, how we have to perform the experiments in the portal. So on the procedure and the animation, this both will help the student to understand the concept properly, and they will not get lost anywhere. So every step there is a guidance and the help is provided by the system. So this is the animation part. Now there is a Viva voice part, which I was telling you via my presentation. So this part I will take after completing the lab. So it will be more relevant there. Now I will go to the lab. So how I have to go to the lab? I have to click on the home button. I will click there and I am again on my home page. I will click on the start and I will click on the let's go to workbench. The workbench is the area where student has to perform the experiment. Now this is the gist which we have thought of keeping when the starting of the lab, that what the student is going to learn. So it says that to learn the addition of fractions with the same relation, we have to follow these steps. We have to first create a grid. Then this grid will represent the denominator part of both fractions. Then from the tools, we will take two different color pens, a red and blue, for creating two fractions. And then we will visualize those fractions and make the addition and come to the conclusion and find the addition of the like fractions. So this is the what we are going to learn part which we have kept. Then the activity starts. Now you can see there is a workbench where the student have to perform the experiment. On the top you can see there is a progress bar also. So any step student will come to know how much percentage they have completed the lab. Then the instructions part which they have to follow. So now what instruction says? Enter the value in the input box and click on the OK button. So what my input box says? To value in the range of 3 and 8. So I will just a second. Diksha is asking for a profile.
Okay. Now you're taking another content.
No, this is the same content.
Okay. But you're taking some other simulation.
No, it's the same simulation, just that the portal was asking some other information, so I moved that.
Okay.
So I will just put the value. From there I will continue. That here you can see I will put a value range 3 to 8, 4 I have options.
Okay.
Now I have entered the value 4, which I was telling that the student will get observation that what they have done. So they have entered a value 4. I will click on the next. Now what system says that we are creating a grid of same row and column which will represent the denominator of the both the fractions. So 4 into 4, 16 cells of grid we are going to create. Now you can see a 4 into 4, 16 grid is created. Now what instruction says? Click on the tools button and select a red sketch pen. The user has to click on the tools button and the student will select the red sketch pen. Now what it's saying? Mark the cells with plus sign sequentially. Now dynamic student can mark as many points. Now I have marked that 6 points are okay. Enter the selected number of boxes, 6. Good, you are right, feedback is there. And what is the total number of boxes? It is 16. So here the button is there for to calculate the fraction. I will click. You can see the fraction represented by red sign is 6 by 16. Okay. So here the first fraction which we have created in the lab of addition of fraction. Now for fraction 2 again the denominators remain same because we are going to perform a lab of a like fraction where denominator is the same.
Now
so again,
what will happen if you put a wrong value?
Okay, I will just tell you here. Now for a blue sketch pen, I have taken suppose 4 and I have mentioned 4. I have to mention here 4. Now if I mention by mistake, I may try to mention 7 and I click outside. So it will say that try again. You have not put the proper value. You have to count the plus signs again.
Oh,
so this will come again and count the sign again. 1, 2, 3, 4 and then again it will change the value. And when it's correct, it will show good. You have choose the right. Okay. And the denominator again, it's a 16. We will calculate the fraction. You can see the next fraction which the student has created is 4 by 16. Now coming to the next. Now you can see here, the first fraction on the screen you can see we have a 6 values 1, 2, 3, 4, 5, 6. The fraction is 6 by 16. The next is 4 values 4 by 16. Until now we have completed the 75% of the lab. Now the resultant grid, we have put all the plus signs. Now what my instruction says that from the resultant grids, enter the plus and sign of red and blue there. So here again you see there is a help provided to the student because the 6th standard lab, the student may get confused. So there is a instructions again to help them that what they have to do, that using grid method they have to find the plus sign and from the above image they can find there are total 5 signs. So 3 red, 2 blue, all they have to count. So they have a 5 signs. Now again we will go to our lab and we will count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I will put the 10 here, right? The system says good, you are right. And then the total number of boxes, it remains the same. I will put 16. Now it's asking me to click on the result button to calculate the final result. Now I clicked on that. Now you can see that the total number of fractions by red sign is 6 by 16, other is 4 by 16, total is 10 by 16, and when then simplified it divided by 2, we can see the resultant answer is 5 by 8. So here the students come to know that the sum of a fraction 6 by 16 plus 4 by 16 is 5 by 8 after simplification. Then again there is a restart button, as I was telling you that based on their pace, students' pace and their choice, they can perform it as many times they want to do. They have to just restart that button and again put the new value, put the new fraction, choose a new fraction, calculate the sum again and simplify them. So like that they can perform the experiment as many times they want to do. Okay. So like them they will complete the lab. Now I will come to Viva Voice part. So this is the instructions for the quiz. It is not a Viva Voice, it is a quiz which tells them how many they have attempted right, how many they have partially attempted, how many they have not attempted.
Okay.
And the best part is that in each quiz we have given an explanation. Now suppose the student is giving a wrong answer, so we have tried to help them that they get an idea that, oh, I was missing this point, so they can correct their answer, right? So I will read the instructions and then I will click on OK. And my quiz is there and there is a timer running on the right hand side. My score is there. There are total 8 questions and this is question number 1. Now the question says Rahul and Komal. Okay, again Diksha is asking to create a profile. Just a minute.
Sure. It's just that you can create a profile one time, put on all the details and then you don't have to go back to it again and again, right?
Exactly. One time they have to be created. So.
Yeah. But this is quite an interesting thing, whatever simulations you're showing, and because we are getting instant feedback, and that's quite interesting because you're learning the concepts at your own pace and you do not require a teacher every time on your head to guide you and to tell you this is not right. It's quite self-instructional, I must say.
Yeah, so it's created like that only. Once the teacher can make the concept understandable to the students, and based on that they can perform it their own. So you can see the question says Rahul and Komal shared a pizza that was cut into 8 equal slices. If Rahul ate 5 slices and Komal ate 2 slices, what total fraction of pizza they eat in total? So suppose I don't know the answer, I will randomly click on any part and try to submit. Now read the explanation. The system says that the answer is wrong, and then the explanation says that add the number of slices of Rahul and Komal that they ate and then divide by the total number of slices in the pizza. So here we are not giving direct answer to the students. We are just hinting them and coming up with the topic where they will make get it on their own and they will perform this lab. So now I get to know like this, and then I will see that the Rahul ate 5 and the Komal ate 2. So 5 plus 2 is 7 and total was 8 slices. So my answer is 7 by 8 and I click on submit. My answer is correct.
Correct, yeah.
Like this, I will go to the next question and I will then try to submit these answers. The student have to perform these all experiments. If they want to skip, they can skip the question and can go to the next part.
Okay.
Again, they can go to the next part and they can reach to the final. If they want to miss some questions, and then again if they want to go to the back to some questions, they can go again back and then they can perform the experiment. Image based questions also we have put, but because this is what we have taught them in the lab. So here student can see, visualize the image, and then based on that they can submit an answer. Now I don't want to submit, I will click on finish. The system will ask that are you sure you want to exit and go to view the scorecard? I will click on yes. Now you see every student we are providing this, that you scored 2 out of 8. Correct answers were 2, wrong answers were 0, partial attempts were 0, and 6 questions I didn't attempt it. And the total time taken to conduct this quiz was 1 minute 48 seconds.
And as you progress, you can also increase the difficulty level of the questions.
Exactly, the questions are there. Based on that, they can change the questions and they can perform it. So like that, the system is there. So these are all the modules which are covered in one topic. Okay. So what they student have to do, I will just quickly recap. They have to read the theory, the short theory which we have kept, then the procedure, how they have to perform, then the animation, they can visualize it, then how it will be happening in the lab, then the simulation, which is the core part where the student have to perform the experiment and come to the learning outcome and the conclusion part. And after that, they have a 10, 20, 10, 15 questions as a Viva voice where they have to complete those questions and then generate their scorecard. So this is a complete ecosystem where students will be very much familiar with this virtual lab and understand the concept. This is what we have thought of. And then again, if there is a other lab which is available, student have to choose here that this is a subsection of lab again from the same topic. So now I will come take one more lab if the time permits. We have some time, right?
Yes, sir. We have almost 5 to 6 minutes left. If you can take a simulation within that time frame, you can go ahead.
Sure,
And,
sure. I will just quickly.
Yeah, if it's possible for you to switch on your camera, then that will be great so that we can have a great interaction also.
Yeah, camera is on, ma'am.
All right, great, sir. Go ahead.
Yeah.
So, what are you taking now?
I'm taking a class 9th lab of area of rhombus.
Okay. Are we done with the experiments of class 6, 7 and 8? All the 3 classes have you taken, sir?
No, I will take that. You want to take me to 10th? I will take to the
Because
classes
sir,
of 6, 7,
in
8.
this journey, we're focusing on the middle stage schooling. So, if you have something that is related to specifically class 6, 7 and 8.
What I'm
Yeah.
Sure. What I'm doing, I'm now going to show you a lab of class 8.
Sure.
And the topic is algebraic identity A plus B whole square.
Wonderful. Yes.
So again, the simulator which I was showing you. So this is the lab which is covered in class 8, which is an algebraic identity A plus B whole square. Now what the objective says that we have to verify that A plus B whole square is equal to A square plus 2AB plus B square. These are the two LOs, learning outcomes, that student will be able to expand and factorize the algebraic identity A plus B whole square, and also student will be able to calculate squares of a number by expressing it as a sum of two convenient number using this identity A plus B.
Okay.
Again, start and let us verify. So as we have short of time, we will not go to theory procedure part, and I will tell you focus on the simulation, which is the core part.
Sure.
So it is the let us verify. Again, what we are going to learn. So it is like to verify A plus B whole square. We have to calculate the number of squares and rectangles. Initially, we will be creating two rectangle squares, and then we are creating two rectangles, and then we are trying to club it together to create a shape which then proves that A plus B whole square is equal to A square plus 2AB plus B square, right? So I'll click on the OK. Again, same, the progress bar is on the top. What I have to do, I have to enter the value of side A and B and click on draw button. Now what it says that the side of square ABCDA in units 10 to 15. So now I will just put 12, and the side of second square PQRS B units, I will just put 14, and I will click on draw. Now you can see two squares, square ABCD with side A and square ABCD with side B has been drawn, ABCD and PQRS. Now what my next instruction says, click on the tools button and select a rectangle. I will click on this rectangle. Now rectangle has been created. Again, tools button, another rectangle. So what we have done, we have a square with value A, a square with value B, a rectangle with side A into B, and then other rectangle with side B into A. Now here we have added reflection that there are four shapes a student has created. He or she may not get lost. To answer this question, what is the square area of this square? This is the A square. This is the B square. This is AB, and this is BA. Now we have identified that. Now next, what they have to do, they have to drag and drop these shapes respectively to different shapes in the square with A plus B. So this is a B square. If I will try to drop it somewhere else, it will not let me drop.
Okay.
See, it has been created like that, that it will fit to a proper place, and then only it will get stuck there. If I will try to drop it there, no, it will not drop. It will drop to the respective place only, like this. Student have to drag and drop all the four parts, and again this is dynamic. They can change the value of A and B, like I suppose use 12 and 14, and they can perform it again. So now all the four shapes have been covered there. Now come to the conclusion. That from the picture we can see that A square plus B square plus 2AB plus AB plus BA is equal to A square plus 2AB plus B square, which is nothing but A plus B ka whole square. So like this is not mentioned in the manual, and with the help of this drag and drop and creating different shapes like the square and rectangle, we have come to the conclusion of this part.
Okay.
So we have approved this. Now also there is a mathematical operation we have kept here, that the student want to change a value, put a value 4 here and random 7 here. Now we have calculated LHS and RHS both here, and 121 is 121. That means LHS is equal to RHS. Therefore, this A plus B whole square is equal to A square plus 2AB plus B square. right? That, so again they can change different values, they can change the value anytime, and they can perform it again and again, and they can click on the restart button and then perform the experiment, and then they can take the Viva voice also, right? So this was the demonstration part which I gave for a class 6 and class 8. There are many labs which are available on the portal, this Diksha virtual labs. A student can come and perform the experiment as per their requirement and needs.
Absolutely, and we have clearly seen that there is no need to actually cram the formulas through virtual lab. You can actually understand how they were derived and how you can use them at the first place, and how left hand side can be proven equal to right hand side. You can also verify the same through hit and trial method also. Now Vaibhav sir, thank you so much for your contribution to this entire session. You not only gave us some really good demonstrations, but the theoretical component was also explained beautifully by you. Thank you so much for your time and presence.
Okay, thank you everyone. Thank you.
Right. So viewers, that was our session of day 5, where we talked about virtual lab for mathematics under the umbrella theme of integration of virtual labs for teaching, learning and assessment at the middle stage. Now we are going to basically wind up the session over here, but it's important to tell you what's coming up tomorrow. So let's have a quick look there. So do tune in tomorrow to know more about virtual lab for sciences. And yes, I told you in the beginning that it's a training program. So make sure that you watch all our sessions very carefully if you wish to attempt the assessment courses that will be released soon on CIT website. Now, before I finally close, it's time to tell you about the textbooks for grade 4 and 7, which are available on Amazon, Flipkart and NCERT website. You can grab your copies from there. And now you can take a look at what's coming ahead. Here is the day's schedule. We're through with a session of virtual labs. In a short while from now, you can watch a session of teaching learning interventions, where we will be taking up the topic of Hindi. And then at 2 p.m. we will bring you a session of mathematics, vegetable farm, followed by a session of Hindi at 2:30. 3 p.m. is the time for session of English between home and school will be the topic, followed by a session of mathematics again at 3:30, and topic will be playing with lines. Today we'll be talking about OER, concept, scope and evolution in our online training program. It's going to be a new journey, and today will be the day 1, and we will end the session and the day with the session Sahyog. The topic is right there in front of you. With this as a wrap, this is me, Harpreet Kaur, taking leave of you, and will join you soon. Namaskar.